Hello, my name is Preston Wilson, and the following is a real quick code review of a project that's actually, I use this for my final project for my computer science degree at Southern New Hampshire University. Um, this is not the complete project here, but I just wanted to review a little snippet of it to get some of the logic that I'm using to do a little review of it. This program is written in C Sharp. I'm using Visual Studio Community for Mac OS. This is ASP.NET Core 2.2. And this is a simple console application that is designed to create a CSV file with mock data to be used for a web application that we created. The idea behind it was to create a mock population that has pseudo-realistic spending habits. And so the following is just going to go over a few really basic concepts of this project. Here, this is our program.cs class. This is our main, where our main method is. This is where the program is launched from. And what I'm doing just to start here, I have two entities that I created, and I'm adding them to a list of entities, which gets passed on to our CSV writer, which was initialized up at the very top of our main method here. And the test entity, just so you can see, that's it. It's just a simple name and a simple ID and a name. And this is the actual writing logic. This takes the list of objects, whatever that object may be. That's what that good T is right there. And it takes the properties of whatever those objects are and has a column for each one. And so, real quick, I'll just show you how it works. Let me give this a more interesting number. Same with this. I'll just run it. I like, for my own personal applications, I like to end it with a read line logic. Oh, I didn't I didn't take note of the directory that this was saved in. Alright, so it is under my projects within the actual project that this code is saved in, under the file that this code is saved in. So let's see, I can follow that path. There we go. Okay. And this is what it created. This little CSV file. And as you can see, it's opening up. And we have our ID and our test name. So what I did for this project is, instead of using these test entities, I have what we're calling a peer. And these peers, they are categorized by age range, salary range, state ID, gender ID, marital status, education level ID, and occupation. Those 7 different attributes that what I have to do for this project is to create a population that has data for each combination of these 7. Um, and the age ranges, we have 7 different age ranges: 18 to 24, 25 to 34, 35 to 44, 45 to 54, 55 to 64, 65 to 74, and 75 plus. Salary ranges 0 to 25,000, 25,000 to 50,000, 50,000 to 75, 75 to 100, 100 to 150, 150 to 250, and 250 and up. States, we have all 50 states plus Washington, D.C., so 51 values here. Just 2 options for gender ID. 4 different options for marital status ID, either single, married, single with kids, or married with kids. We have 5 different education levels and 25 different occupation IDs, and these IDs were gathered from the Bureau of Labor Statistics. They range from farming and agriculture to business to clerical, personal service, security, transportation, different things like that. And what I have to do is to create a population with that has values for each combination of these 7 attributes, and generate salary, investments, retirement savings, bank savings, pension, life insurance, annuities. And so there's quite a bit of data that needs to be created for this project, and instead of simply relying on, like, say, the C#'s random class, when I first did that, I had values ranging. There was no logic to the values. Even putting constraints in some of them, I would have, individuals making $50,000 a year but having $5,000 mortgages, and so what I had to do to get around that is take all of this expenditure data and break it down into one of 4 categories. It can either be an asset, which is investments, retirement savings, bank savings, pension, annuities, Social Security, real estate, and forecasted income. It can be debt, so that's our car payment, mortgage and rent, student debt. It can be spending, so food and dining, entertainment, children activities, or mobile. Or it can be savings, so we have a savings and a retirement. And so what I had to do was take the fields here and separate each of them into one of those 4 categories, treating the entire peer model as a whole, and then randomizing how much of that whole will be taken up by each of the 4 different models that make up the peer. And that, in essence, is a very quick rundown of what my final project is intended to do. Thank you for tuning into this, and I will attach artifacts to this page as well, with explanations as to how I went about accomplishing this feat. Thank you very much, and have a wonderful day. Goodbye.